Hey everybody, it's Mr. Hanley here. I am just finishing up the chapter. We have just a couple of terms left. You may have been working on your practice books, and we had a couple other terms to go. So I just want to go. This should be a pretty quick video. On page F28 of your science book, we had gone through. We were going through simple machines. Let me go through the first couple again just to review really quickly. We had a lever. A lever is kind of like a seesaw. It goes back and forth, has a turning point, a load, and a force. Actually, I used leverage at the golf course. I was working at the golf course the other day, and a tree had fallen, and it had gotten pinched. The saw blade had gotten pinched between two parts of the tree, and the saw blade was there, and we needed to pick up the tree because what happens is, as the tree, picture this as the tree, as the tree falls, it goes like this, and the saw blade is in between it, and it goes like this, and it pinches, like, if you picture it, there's like a cut into it, and as it falls, it goes that. That's probably a better analogy. So as it falls, it goes like this and squishes the saw blade. Well, I had to pick the whole thing back up, but it was too heavy to pick up, so I used a big log, and I put it underneath like this, and I I'll draw it actually. I had the log was like this, and there was like a cut in it, and the saw blade was here, but as it was falling, it was squishing the saw blade, okay? So I needed to get it back up again. So what I did was I took another log and put pressure on it this way, and because the log was really long, actually I put pressure more like this way, I was able to push it upward and move this log upward because it would give me more strength than I normally had. So it's a lever. We had a pulley. A pulley is like a rope around a wheel. And remember, I said it has the same output as same input and output. Meaning, like with a lever, I was able to put like 200 pounds, put 50 pounds in and lift up 200 pounds or something like that. With a pulley, you pull 100 pounds and lifts 100 pounds. The same exact. So the reason why it's useful, though, is that it changes the direction that you're going in. You're pulling down, and the thing's going up, okay? And the other one was a wheel and axle. There's a small axle and a large wheel that extends it out. It's kind of like a lever on every side. The next couple, an inclined plane. An inclined plane is something that we would call probably a ramp. We'd probably call it a ramp. Looks like this. Okay, that would be an inclined plane. We'd call it a ramp. You go up like this. What it does is, if you have to, let's say there's a platform right here. Okay. Instead of walking over, and you're, let's say, a person this tall, okay, and you have this heavy box, okay, heavy box, okay, you're trying to lift it, you got sweat coming off, because you're trying to lift it, it's so heavy, okay, it's heavy. Trying to lift it, instead of lifting it all the way up there, okay, instead of having to pick it up and lift it above your head and lift it up there, you can instead just go around here and just go and just walk up the ramp. You see, there's an exchange. With a ramp, there's an exchange. You increase the distance that you travel in order to decrease the force that you output. Okay, that's with a ramp. Think about it. Is it quicker to go up here, like a shorter distance? Yeah, this is a shorter distance, just right in front of you. Just lift it straight up, right? Versus this is a longer walk. Or you can think of stairs, at a restaurant or something like that, you might, or whatever place, there might be like 5 steps up. 5 steps up is much quicker than going, like, sometimes there's a ramp that kind of goes up and around. Let me draw that too. You might be at a restaurant, or I'm thinking of, I don't know if anybody has ever been to Stockholders in Abington, has one like this. That place is delicious. It's like one of my favorite restaurants. We Mrs. Hanley and I rarely go there because it's expensive, but I think one of my birthdays, one time I went there and it was so good. I like a good steak. So, like this. So the stairs come like this, right? These are my stairs. They aren't very good. Those are terrible stairs, okay? Pretend those look like stairs. Okay, there's a few steps here. Okay, I really usually can draw stairs a lot better. I don't know why those look so bad. But you have the stairs like that, okay? Okay, pretend those look like stairs. So you have the steps that you can go up this way, or there's a ramp that goes up and around like this. Like that, so you can go around and around. Okay, now for somebody who is able-bodied and you're not carrying anything really heavy, it usually makes sense just to go up the stairs, because this is a really long way. It's like, in real life, it's like 45 feet or something like that to go around this way. So if you're just walking, it doesn't really make very much sense for you to go this way. But let's say you were carrying something extremely heavy, okay? It might make a lot more sense to go this way rather than trying to lift it up. And pretend these aren't even stairs. If this was like just a 5 foot high drop, and you had to put the package up and climb up and everything, it would just be easier to go this way. Especially if you have some sort of, dolly or something that you're pushing things on. So ramp can make work easier by increasing the distance in order to lessen the force. I mean, think about it. If you have a hill, let's say you have a hill here, and you're climbing up the hill. If anybody has ever been on a steep hill, the kind that's fun to roll down, instead of going up the hill like this, instead of going straight up the hill, you might climb up the hill this way. Okay, you might climb up the hill that way, because it's actually easier to climb the hill at a slight incline. I dropped it again. I just tried to put my cover on my marker. It might be easier to go sideways almost than going straight up, and it increases the distance, but it's less work. That's an inclined plane. If you take two inclined planes and put them back to back, so let me show you what happens. Let's take two inclined planes. Okay, you have an inclined plane right here. Okay, and you have another inclined plane. You put them both back to back, you get what's called a wedge. This is not a wedgie, it's a wedge. A wedgie is something else. Okay, a wedge. What a wedge does is it gets between things. So does a wedgie. But a wedge fits between places, and you see this front end, okay, is able to push things. Like, for instance, a typical wedge that you see is an axe blade. Okay, an axe blade would look somewhat like this. Okay, kind of comes down here, and it has this sharp part. Okay, it's also hard to draw because I'm not really looking. I'm like looking from the side. Okay, and then you have the handle coming here, coming out here. It doesn't have a really very good axe blade. Okay, so your axe is coming down. So your axe or your hatchet, it comes to a point. What happens when you have this piece of lumber that you're cutting? Let's get some rings going here on this. I don't know why I feel like drawing well today. I feel like putting more into my drawing today. But so you have the log that you're cutting today, and what happens is as you come down on the log, it actually splits the log apart. What happens is the log comes here and hits the wedge, the axe, and as it hits here, it's deflected off. It hits here and it's deflected off. Okay, so each side is deflected off and starts splitting apart. the wedge moves them apart. You do the same thing when you dive into the water. How do you dive into the water? What do you do with your hands? You don't go like this into the water unless you're falling. You usually do this or something like that. You're making your hands into a wedge like this or like this. And so, pause. And so you're using a wedge to push the water apart. Think about it. When you dive, your body looks more like if this is your body, legs or whatever, and your head and your arms coming to a point here, okay? When you're diving, you kind of look like you're a wedge. These are your legs back here, okay? And your swimming trunks, okay? And you're diving in, okay? You're kind of making your body into a sort of wedge versus a belly flop. Think of what a belly flop looks like. You have an increased surface area. So with a wedge, you have a smaller surface area, smaller, and the sharper it is, the more it can cut through things. And that's a wedge. It splits things apart. The point of a wedge is to split apart. The last simple machine is called a screw. Okay, you guys all know what a screw is, but let me describe how it works. Okay, let me go this way this time. Okay, you have a nail. Let's say you have a nail. The nail has this much surface area. Okay, what is holding onto the wood is that much. Okay, that much, however many pounds per square inch or whatever, is holding onto the wood is that much. Well, with a screw, okay, you have the same length, but it has these threads around it, okay? And what happens is if you take, essentially the thread acts like an inclined plane. It kind of goes around and up the side of the thread. And if you were to take the thread and stretch it out, you'd have a much, much, much longer. Pretend you take these threads around the screw and stretch them out, it'd be this long. So there's that much grip in the wood. That's why screws hold way, way better than nails. If you were to put something and you want it to hold, you want to use screws rather than nails, usually, because they hold better. So a screw is essentially, a nail is a wedge, and a screw is a wedge with an inclined plane wrapped around it. Okay? That is all we need to talk about. This was actually longer than expected, maybe because I did too detailed of drawings, but that is it for lesson 2. In lesson 3, we're going to get into Newton's law of gravitation. F equals G times M1 times M2 divided by R squared. I don't think we're going to go that deep into it, nor will you have to know that G is 6.67 times 10 to the negative 11. But we'll just talk about how everything is related by gravity. See you guys.